Exercise 20. This is Fourier analysis, and a lot of these problems are really long and really computational. Nice, but computational. But then you've got problems like this. So, here's how we do this. So, we want to prove that PF is in L1Rn. So, we compute integral over Rn of PF x dx. What is this? This is integral over Rn of the integral over Rm of f xy dy dx. This is less than or equal to integral over Rn, integral over Rm. Now let's write it on the next line to make it not just, well, you'll see why. Integral over Rn, integral over Rm, fxy dy dx. But then by Fubini's theorem, well, technically this is Tonelli, because this is a positive function on a sigma finite measure space. And so we can write this as this double integral as a single integral over the product space. But what's that going to be? That's just going to be f1. So I guess here's the proper way to do this part. When we write this, we don't know a priori that this is even defined. So what you do is you go backwards. You say, oh, well, we know f is in L1. And so f1 is equal to this, but this is greater than or equal to this, and this is equal to this. Therefore, this is in L1, and therefore this integrand is in L1, and this is greater than or equal to this. But, I mean, that would involve things like words, and here I didn't have to use that. Next, we want to compute the this thing, the Fourier transform of PF. So I'm going to make this a semicolon and then continue with PF, Fourier transform of C, I think is how you say it. But anyway, this is equal to Rn e to the minus 2 pi I xi, whatever, I'll just call it xi. Pfx dx. What's this equal to? Rn e to the minus 2 pi I zx integral over Rm fx y dy dy dx. This is equal to, well, what can we do here? We bring the integral outside, Rn, Rm, then e to the minus 2 pi I. Certainly this is going to be what we get when we do the dot product of xi dot x with 0, because xi times x plus 0 times y is just xi dot x, so this is just a simple manipulation. xy dy dx. But then, oh wait a minute, we can use things here. What can we use? We can use Fubini's theorem. And then, once we use Fubini's theorem, this is equal to f hat of xi of 0. And there we go. Didn't even have to write any words down. Well, I had to say the words, but this is it.